Hey folks, estimating a population proportion. We are going to learn about confidence intervals and we're going to get introduced to the central limit theorem. So we're going to learn a bunch of good stuff. And I keep referring to this section, or in the beginning I refer to it as 9.1. Just ignore that. This is all about estimating a population proportion. Okay, take care.
Hey folks, chapter 9.1, estimating a population proportion. Okay, so you probably see things like this in the newspaper or online when you're reading the news. Here's my example. In a recent survey, 70% said they would vote for candidate X. Okay, so you get the percentage of people that are apparently going to vote for your candidate. And then you'll notice at the bottom of the page, there's usually some small print. It says something like, oh, plus or minus 3%. With 95% confidence. So basically what that means is, so the plus or minus 3%, that is our margin of error. I don't like that they use the word error. Makes me think of a mistake. There's no mistake. It's just the margin of error. Whenever you're sampling, things don't work out perfectly. So plus or minus 3%, our margin of error is 3%. And our margin of error is represented by the symbol capital letter E. So we could write a confidence interval. So we could say, plus or minus 3%. So 70% is our point estimate. So 3% below. So if I subtract 3%, that's what, 67%. And then if I go 70% plus 3%, that's 73%. So my confidence interval is, I think the percentage of people that are going to vote for my candidate is between 67% and 73%. So this is my confidence interval. We're going to learn how to make these. So this is just an example to sort of give us a feel for what's going on. So this 70%, that was done based on a survey. So that's technically just my p hat. P hat's my sample proportion. P hat is a sample proportion, sample proportion. It's sometimes referred to as a point estimate. So a point estimate as opposed to a confidence interval. So let me switch colors here. The confidence interval has a lower bound and an upper bound, and the point estimate is just a single number, a single point. So the 70% would be my point estimate. So at this point in the game, we only have one point estimate. It's p hat. Looking forward in the future, x bar, sample mean, will be a point estimate, and we'll get a confidence interval for that. So notice how we're kind of saying the same thing here. Oh, candidate X, what percentage of the people are going to vote for him? Point estimate, oh, about 70%. Okay. How many people are going to vote for him? Oh, probably between 67 and 73%. Okay. So you see how this point estimate comes with a margin of error. So the point estimate, when combined with the margin of error, would give us our confidence interval. Okay, let's make sure we got all the vocab. Point estimate, confidence interval, p hat. Oh yeah, just like we have x bar, we have p with a little thing above it, p hat. So if I were to draw it a little bit prettier, it's p, the little sort of hat on top of it, p hat. Its name is sample proportion. Similar to x bar, which has a name of sample mean, p hat is technically our sample proportion. It happens to be our point estimate. Okay, so tell me if this makes sense. Our confidence interval, we didn't really talk about how many people we surveyed, but if I talk to more and more people, the more people I talk to, tell me if this conceptually makes sense. The more people I talk to, the more convinced I should be that that number is good. So the more people I talk to, my confidence interval should get smaller. So the more people I talk to, the confidence interval should get smaller. Hopefully, conceptually, you are good with that. Okay.